Okay, what we're going to look at today is a whole number divided by a fraction. So let's say I have, whoops, let me get my pen. Let's say I have this expression right here. And the way we typically would read that would be 2 divided by 1/3. Well, if we're used to dividing by whole numbers, this can look kind of weird. Like, what does that mean? 2 divided by a fraction. And we call this a unit fraction because in the denominator, or in the numerator, there's a 1. In the denominator, it doesn't matter what number you have. But in the numerator, there's a 1, so that's a unit fraction. So when I look at this, I think, well, let's take a second and think what we know about just division of whole numbers. So let's say you had this easy problem, 8 divided by 2. Let's see, 8 divided by 2, you know your math facts. But what that's saying is how many 2's are in 8. So let's say that this whole rectangle equals the number 8. Isn't it true that if you had 4 2's, that would be 8? So yeah, that answer is 4. So remember, the question is how many 2's are in the number 8? And when we look at this down here, there are 4 2's in the number 8. Okay, let's take that thinking and use it for dividing fractions. So let me think now. 2 divided by 1/3. Okay, what's the question? The question is how many 1/3's are in 2? So you want to think about that. How many, whoops, I need my pen. How many 1/3's are in 2? Okay, well, let's draw 2 holes. So we act like those 2 circles are the exact same size and shape. Okay, well, let's see how many 1/3's are in 2. Well, let's count it together. 1, 2, 3, 4, 5, 6. There are 6 1/3's in the number 2. And when you look at this, at these 2 circles, each of these pieces is 1/3. So when you count them up, that answer there is, I could squeeze it in there, 6. So the last bit I'm going to do on this is to think about it in terms of, let's say, a story problem when we have a whole number divided by a unit fraction. So let's say there are a bunch of kids, we don't know how many yet, and each child is going to get 1/4 of a pitcher of lemonade. So, and there are, let's say, there are 3 pitchers. So let me get that on. 1, 2, 3. I'll put a little handle on it so we know they're pitchers of lemonade. Okay, so each child is going to get 1/4 of a pitcher. So let's see. The first child gets that much, it pours out. The second child gets that much. The third child gets that much, and the fourth. You could probably see where we're going with this. So what I'm trying to figure out is how many 1/4's are in 3 holes. And the way I would write that as an expression would be 3 divided by 1/4. The question is how many 1/4's though are in 3. Okay, so now I'm going to go over here, and the 5th child gets that, the 6th, the 7th, and the 8th. Oh, looks like we could give more kids lemonade. The 9th child gets that, the 10th child, the 11th child, and the 12th. Oh, so we'll have enough lemonade when each child gets 1/4 of a pitcher. We'll have enough lemonade for 12 kids. I want you to think about, before I end this video, do you see anything interesting in this equation here with maybe multiplication facts? And that's just kind of a hint that I'm asking you on that. We are going to start out, as we're looking at these, drawing it. But if you can write the expression and then write it as an equation, because you'll have the answer. If you start to see a pattern in there with multiplication facts, start to use that. And that's it. Have a great day, and thanks for listening.